This is what we know about the turn of events in our own universe. All the way back to the Big Bang. Well, it was more of a rapid expansion that happened over a long time, but we'll stay away from the specifics here. Using fancy satellites and stuff, we see that the universe is expanding over time to this day. Now, turning it back all the way, we find that the universe all was contained in an almost unbelievably tiny space. Basically a pinhead. Isn't that crazy? All of the things that we ever saw, or can see, like you and me, fit on a pinhead back then. The universe was a strange time back then. In fact, one of the reasons why it was so hard to figure out what it looked like is that light didn't even really exist back then, per se. Everything was too closely packed in for light to even be able to travel through any of it, so you couldn't see even if you were back there. All this junk even messed with the fundamental forces of our universe. They're known as the strong force, weak force, electromagnetic force, and gravity. Even the strong force was no match for how crazy hot and hectic it was back then. But let's try to stay away from the specifics. Eventually, as things began to expand, the universe cooled down, and all that junk that was squished so tightly started settling into more familiar kinds of matter. Skipping ahead, sort of a long time in terms of time, but trust me, not a lot really happened. We start to get this spread of what basically is hydrogen. These elements thrown out and about space eventually were drawn to each other by gravity. And as more and more of this dust clumped up a lot, this ball of hydrogen would eventually get so massive that it would start to compress within itself to create a star. Stars are very important to the formation of the universe. They're basically the furnace where all the hydrogen got slowly baked into bigger elements like helium, carbon, oxygen, etc. The poetic thing about the way they distribute these elements that we need to make life is after finish baking all these elements, they get to a certain point where they run out of juice. The stars at this point will either slowly die out and become smaller, denser, dimmer stars, or they will go crazy and explode, and release all of the valuable elements throughout the universe. After this kept happening for a really, really long time, where stars came and exploded countless times. Eventually, enough of these more complex elements gathered into planets around a specific star, which we call the Sun. The direction that all this stuff spiraled into itself, like a drain in your sink, is actually the same direction that all of our planets orbit the Sun to this day. For the most part. One of these giant rocks orbiting our Sun gathered more and more asteroids and such, which brought it lots of resources like water and precious metals. And over time, gases got trapped on this giant rock and gave it an atmosphere. This giant rock is what we call Earth today. The Earth may not seem like it, but it also has a heart. The core is actually incredibly hot. Hot enough to melt rocks, and a lot of it too. The whole Earth, at least the part that we see here on the surface, is actually barely just the skin. Something similar to the skin of an apple. The Earth was very hot early on. The surface had a lot of lava. Maybe some asteroids made of ice helped things along, but eventually things settled down enough for liquid water to start to pool on the surface. Skipping ahead a while, the energy from the core, the sun, and other random occurrences caused things to shift around on Earth over time. Eventually, some of the chemicals scattered around Earth got together, and we got really lucky. It might have been just a random occurrence, but some of these chemicals stuck together and made molecules. Many of these molecules over a long time probably didn't do much of anything, but eventually, over enough time, they got settled into cells, or just some kind of barrier that separated themselves from the rest of the universe. This probably came and went a bunch of times over, but eventually, one of these cells stuck around long enough to split roughly in half, and now both halves were lucky enough to stick around and get bigger and split again. How lucky, right? After there were more and more of these cells that kept sticking around and multiplying, they stuck around even longer, probably for a really long time again. These cells somehow managed to use resources like sunlight, underwater vents, or maybe some other chemical resource to store as fuel, to keep multiplying. Eventually, these cells got pretty good at sticking around. Over time, some of these cells changed into a cell that would get its energy from other cells. It would basically eat them. And over time, they would multiply and change over time as well. It took time, but these cells started getting more and more complex. They started to get sturdier. They grew cell walls and complex structures to make it easier to survive. Skipping ahead again, we jump to what would be easier to see as alive, like plants and fungus. Plants were very important for the development of the rest of us because plants started to use the sun's energy to change all of the old air that we couldn't really use, carbon dioxide, to something that we can breathe, oxygen. Oxygen is really important because it makes a lot of energy, and easier than carbon dioxide too. I imagine that the kids of the cells that didn't eat the other cells turned into plants, while the kids of the cells that ate other cells stayed in the oceans and kept doing that, kept eating each other. These now animals in the oceans kept eating each other over a long time. Eventually, one of them got sick of it and tried to leave the ocean and go to land, probably to avoid getting eaten. A bunch of them probably tried, but one of them got lucky enough to do it good enough to be our great-great-great-great, etc. grandfather. He probably just looked a lot different than you and your grandfather right now. Over time, this fish that made it to land had kids, which had kids, which had kids, etc., etc. And eventually these grandkids changed and diversified. They started to look very different from each other. They grew scales, they grew skin, they grew big, and they grew small. As long as you stayed alive and kept reproducing, things kept diversifying. Let's jump ahead to the dinosaurs. Dinosaurs had a great advantage early on because of how easily their bodies allowed them to evolve and grow in size. Back then, bigger usually was better, because bigger meant you can eat the smaller animal. But bigger wasn't better when something like a big asteroid came and hit the Earth. It caused the atmosphere to wildly change, and big creatures like dinosaurs really suffered. Dinosaurs are actually still alive today, it's just that their great-great-great-great-grandkids now have fancy feathers. People think that they might have had feathers for a while too, actually. It's hard to tell these things precisely looking at fossils. The mammals, on the other hand, at this point, something mostly like a mouse, survived because they were wily. They were mostly just small, but that helped. After we were free to now grow and spread, because the dinosaurs were knocked down by the asteroid, mammals began to flourish. Mammals began to diversify and even started having bigger brains. One of these mammals, in what we now call Africa, lived in trees. These mammals that looked a lot like apes were pretty cool. But it seems some of them didn't want to share these trees. So these mammals that were kicked out of the protection of the trees had to deal with predators like lions out in the savannah. Some people think that this is around the time that these animals walking on the savannah got really lucky. Maybe it was lightning that caused it, but regardless, a fire was created. And from this fire, one of these mammals was brave enough to try to tame it. That was very revolutionary. Fire was very helpful for fending off predators and allowed these animals to cook their food. Yummy! But not just tastier. The heat actually allowed these animals to more easily break down the nutrients in the food that they were eating. This is actually very exciting because it allowed us to be able to use more resources in our bodies for things other than digesting food, like growing our brains. It turned out that being smarter was actually the most effective way to survive. Over time, as the smarter animals kept getting smarter and better at using fire, we became clever enough to use tools. We used tools to make better tools, and so on. These early versions of us were very successful. They spread from this particular savanna to all around the world. They spread out from Africa to different countries, and eventually cultures developed from these different groups of early humans. From tools, we made better tools. Some tools were tools to help make better tools as well. We developed art, languages, cultures, religion, science, etc. We learned how to utilize stone tools. We learned how to utilize bronze, steel, electricity, etc. We even made complex systems that help us make us who we are today. Then eventually, you and I were born.